Algebra 2, Common Core, Exponents. So Unit 7 for us is a chapter on exponents, and there was no video for 7.1 because what we did in class was just review some very basic exponent properties you should already know, like when we multiply a common base, we add the exponents. When we raise an exponent by an exponent, we multiply. When we divide, we subtract, things like that. So this video is 7.2, and this is just the title page for videos 7.2, 7.3, 7.4, 7.5, 7.6, but this video is just 7.2. And 7.2 is, again, a basic exponent stuff that you really should know, such as zero exponents and fractional exponents and negative exponents. So we'll cover these three exponent concepts in this video. And I believe all three of these you should have learned in Algebra 1, but these are probably the three most advanced exponent concepts you should have learned, so it's worth taking the time to review them again. So zero exponents, very simple. Any base raised to the zero equals 1, regardless of that base. So if we look at a couple of examples here, this got edited kind of weird, but 5x to the 0, that whole thing is being raised to the 0, so this whole thing equals 1. This is b. This is supposed to be over here, but that's okay. The difference here, let me rewrite this so there's a little more space here, 5x to the 0. The difference between that and this is the parentheses. And so parentheses are very important in mathematics in general, but they come up a lot in exponents, and that's something that trips up a lot of students. So make sure you're very careful with the exponents. What is the base of that exponent? In this first example, the whole base is 5x. In this example, only x. So because only x is being raised to the 0, that is what becomes 1. Only x to the 0 is 1. And this 5 is still just 5, and we get 5 times 1 is 5. The 5x to the 0 versus 5x to the 0, they sound the same, but you gotta, where is the parentheses? It could equal 1, it could equal 5. Here's another example. Again, this whole thing is being raised to the 0. It doesn't matter that it's negative. Whatever the base is, no matter how many terms are in there, no matter how complex, if the whole thing's being raised to the 0, it simply equals 1. Fractional exponents, we have a little formula pattern here that x to the a over b equals the bth root of x to the a. You could think of a fraction exponent as power over root. Power over root. That's a pretty terrible R there, but I think you know what I'm trying to write there. Power over root. So if we had something like, let me give an example of, well, let me do something with just simple numbers to show you what I mean. If I take 4 to the 1/2, the most basic I could think of here, 4 to the 1/2, what's happening is that the bottom of the fraction is the root power, power over root. So the 2 means 2 root, which is square root. So it's really the square root of 4 to the first, and the square root of 4, of course, is 2. You can confirm this in your calculator. Just type in 4 to the 1/2, and you will get 2. So basically, an exponent raised to the 1/2 is the same thing as square root. Something raised to the 1/3 is the same thing as cubed root. But then when you throw things other than a 1 on top, like if I take that 4 and I do 4 to the 3 over 2. There's two ways to think of this, and you could do this in any order, and that's true for a lot of exponent stuff. There's a couple different ways to approach it, but I could think of this as the square root of 4 and then that cubed, or I could think of the square root of 4 cubed. Either way, the top of the exponent is the power, so like that cubed it's going to be cubed. The whole thing's raised to the 3rd. The bottom means square root, and so you could do it in any order. I prefer to do the root stuff first, make the number smaller, and then make it bigger again with the power. So I like to do root first, power second, but it goes both ways. So this is square root of 4 cubed. So the square root of 4, of course, is 2, and 2 cubed is 8. 2 times 2 times 2. Or I can think of it as a square root of 4 cubed, and 4 cubed is 64, and the square root of 64 is 8. So we see it does work both ways, but I tend to prefer to do the root first. Now this example, we're just using x, so there's not, really a right or wrong way to do this. You just have to know that now this is, I don't like this notation, that x to the 3 slash 5. That's 3 over 5. And so the bottom, the denominator of the fraction is 5. That is fifth root. And the fifth root of x cubed, so that'd be choice D. Number 5, what is happening here? So this is 4x to the 1/2. Again, notice the lack of parentheses. So that means that only x is being raised to the 1/2. And so 4 is, nothing's happening to the 4. It's just being multiplied by x to the 1/2. And anything to the 1/2 is, like I said, square roots. This is 4 times the square root of x. All right, negative exponents. The key for negative exponents is reciprocal. Remember what reciprocal means. Like if I take the reciprocal of 3 over 4, the reciprocal is 4 over 3. It does not change signs. It simply is flipped upside down. Sometimes people want to change the signs because they're thinking back to geometry when you did perpendicular slopes. Perpendicular slopes are negative reciprocals. Regular reciprocals is just flip it upside down, keep the sign. So this is a positive fraction, its reciprocal is a positive fraction. And we talked about this when we did trig, like when sine is positive, its reciprocal cosecant is positive. But what's happening here is negative exponents cause reciprocals. So something raised by a negative exponent, you get reciprocal of that. Here's a fraction. Now this wasn't a fraction, but we know we could think of it as over 1, so we got reciprocal to 1 over a, and then, you could, 1 to anything is just 1. Apply that exponent to the top and the bottom, we could look at it like this. But if you already have a fraction with the numerator denominator raised to a negative exponent, you simply do the reciprocal of it, and then the exponent becomes positive. And then you could apply it from there. So again, if we take that example of 3/4 to the negative second, of course I could just type this into my calculator, but I can do the reciprocal of the base to make it 4/3, and then my exponent is positive. So reciprocal base, change the sign of the exponent, and then simplify from there. 4 squared is 16, 3 squared, 9. Let's look at a couple demos here. 5 to the negative second. Well, 5 is not a fraction, but we know we can think of it as over 1. So when I flip it, it's 1 over 5 to the positive second. That would be 1 over 25. You could, again, just like I said, the order can be done a couple of ways. You could always square it and then do the reciprocal of that, but I like to do reciprocal first, then apply the positive exponent. Okay, 2a to the negative fourth. Again, notice the parentheses here. That's very important. So this whole thing is over 1, so when I do the reciprocal, 1 over 2a, and now the whole thing's being applied with a positive exponent of 4. Another common mistake is, it means reciprocal, but people like to reciprocal the exponent. That's not what happens. You reciprocal the base, change the sign of the exponent. Reciprocal base, change the sign of the exponent. You do not reciprocal the exponent. One of the reasons why people mess that up is because later on in this chapter, we will reciprocal the exponent. But that's when we're doing equations and moving things to the other side of the equal sign. So that's very different. If you're just simplifying an expression, you don't reciprocal the exponent. You only negative exponents cause a reciprocal base. That's really the key here. Negative exponents cause a reciprocal base. Let me write that down. Negative exponents cause a reciprocal base. That's really the key here. So reciprocal the base, and then you get a change exponent to positive. All right. So this was 1 over 2a to the fourth, and then 1 to the fourth is just 1. Don't forget this whole thing's being raised to the fourth. So 2 to the fourth is 16, and a to the fourth is just a to the fourth, so choice D. And I think, what do we got? One more here. So which is equivalent to this? So this kind of combines a couple of things. We have a negative exponent with a fraction exponent. So we have to do kind of two pieces here. First, I always like to deal with the negative exponent first. Turn that to be positive, and then you're just dealing with positive exponents. So reciprocal this whole thing, again, if the whole thing's over 1, so 1 over 9x squared y to the 6th, and now it's being raised to a positive 1/2. I did not reciprocal the exponent, only the base, but the exponent did become positive. Now doing the square root of this, well, the square root of 1 on top, of course, is 1. And that rules out pretty much all these other choices. It is going to be a, but let me explain the rest. The square root of 9, of course, is 3. And then the square root of variables, when you're doing something like y to the 6th, now this is square root, so let me put a little 2 out there just for reference. When you're doing this type of thing, you divide the exponent by the root. So 6 divided by 2 that's why it's y to the 3rd. X squared, the square root of x squared, I'm doing a root of 2. 2 divided by 2 is just 1. Y to the 6th divided by 2 is y to the 3rd. So when you're doing radicals with exponents, you divide that concept. All right, kind of like when an exponent is raised by an exponent, you multiply. It's the opposite of that. So that's what's happening here. That's choice 9. So 0 exponents are 1. You got to be careful with parentheses. Fraction exponents, think about it as power over root. And negative exponents cause reciprocal bases. All right, that's it for some basic exponent stuff. Our next video, 7.3, will get into equations with exponents, and this is actually where we'll see that reciprocal exponent concept. But that's an equation thing. This is a simplifying thing. You got to keep them separate. All right, that's it. See ya.